And come on. There we go. All right, the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so today, eventually, we're going to go on to section 7.3, but first I have some requests from you folks, so we'll start by looking at those. This is from section 7.1, number 21. It says, simplify the expression if possible. And the expression is the following: 81a squared minus 1 over 9a plus 9. All right, the numerator of this fraction is the difference of 2 squares. 9a plus 1, 9a minus 1. The denominator of this fraction, we'd factor out the greatest common factor, which is a 9, and we end up with 9 times the quantity a plus 1. Well, there are no common factors in the numerator and the denominator, so we can't simplify it further. So the correct answer is does not simplify. Any questions about that before we go on to another example? Okay, give me just a minute here. Let's see, 7.2. Number 9. Okay. This is from 7.2, number 9. Multiply and then simplify if possible. Okay, so we've got x squared minus x over x times 4x minus 12 over 4 minus 4x. So the first thing we want to do is factor each of the numerators and the denominators as much as we can. So x squared minus x, we're going to take out an x and we get x minus 1. The denominator is still going to be just x. 4x minus 12, we'll take out a 4 and we get x minus 3. 4 minus 4x, we take out a 4 and we get 1 minus x. Okay, so what can we get rid of? Well, we can reduce out the x over the x to 1 over 1. We can reduce the 4 over 4 to 1 over 1. But look at this. There's that pattern. A number divided by its opposite. So that reduces down to a negative 1 over 1. So I've got a negative 1 times x minus 3. And I could write that as negative times x minus 3. Or I guess I could distribute it as negative x plus 3. This is a multiple choice one, and this one isn't listed. This one is offered as a possible answer. All right. Are we okay with that one? Any questions there? Okay. Let's see. Here. And 7.1. All right, this is 7.1, number 11. Says simplify, assume that the denominator is not 0. 40x to the 6th divided by 16x. Okay, so 40 over 16 could be reduced. We could take out an 8 and get a 5, take out an 8 and get a 2. But this is where the problem was for the student. So let's take a look at that. X to the 6th over x. First of all, there's an implied 1 exponent on the denominator. So what's the rule when you're dividing 2 powers with the same base? It's the base with the top exponent minus the bottom exponent. So this over this is going to be x to the 5th over just a 1. So that's going to give us 5x to the 5th over 2. Okay. And it looks like what the student did was they added the exponents. If we have this situation where we're multiplying two powers with the same base, that's where we add the exponents. But when we're dividing two powers, we subtract the exponents. All righty. Any questions on that? Okay, this is also from 7.1, number 15. It says, simplify, assume that the denominator is not 0. 2 times the quantity, t minus 1, plus 2, over 2t plus 2. So we need to multiply the numerator out, get it all distributed and combine like terms and everything, and then try and factor the whole thing. So up top, I've got 2t minus 2 plus 2, which is 2t. And on the bottom, I've got 2 times t plus 1. So I can reduce out the 2's, and I'm left with t divided by t plus 1. Any questions about that problem? Okay. Let's see here. Now we're going to 7.2. Number 21. Okay, this is a long one. I hope you brought your lunch. 7.2, number 21. Divide and then simplify if possible. So we've got x squared minus x minus 6 divided by 2x squared plus 7x plus 6. All of that divided by x squared minus 49 over 2x squared plus 17x plus 21. All right, first thing I'm going to do is change it from dividing by a fraction to multiplying by its reciprocal. So I'm going to get x squared minus x minus 6 over 2x squared plus 7x plus 6 times 2x squared plus 17x plus 21 over x squared minus 49. Okay, so dividing by a fraction is like multiplying by its reciprocal. Next thing I'm going to do is I'm going to factor the easy ones first, or I should say the easier ones. X squared minus x minus 6. We're going to have an x and an x. Product is -6, sum is -1. How about -3 and plus 2? Would that work? I believe it would. Okay. Then on the other side, x squared minus 49 is going to be x plus 7, x minus 7. So now let's go back and let's take this trinomial. I'm going to take that and recopy it on the next page. So I've got lots of room to work with. So 2x squared plus 7x plus 6. It's a trinomial in standard form. It has no greatest common factor. It's not a perfect square. It doesn't have a leading coefficient of a 1. I'm going to use grouping unless you request otherwise. So A is 2, B is 7, C is 6, product is 12, sum is 7, the numbers are 4 and 3. So 2x squared plus 4x plus 3x plus 6, factor by grouping. Greatest common factor, 2x, x plus 2 left over, x plus 2 left over, 3 comes outside, x plus 2, 2x plus 3. So I'm going to take that and transfer it back on the previous page. X plus 2, 2x plus 3. X plus 2, 2x plus 3. Okay. Any questions there? Now I'm going to take this one and go to a page down below. 2x squared plus 17x plus 21. 2x squared plus 17x plus 21. Again, we have a trinomial in standard form, no greatest common factor, not a perfect square, doesn't have a leading coefficient of a 1, blah, 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 blah. I'm going to use grouping. A is 2, B B is 17, C is 21, product is 42, sum is 17. How about 14 and 3? Okay. So 2x squared plus 14x plus 3x plus 21. Group it, take out 2x, x plus 7 left over, x plus 7 left over, take out a 3. Okay, so now I'm going to take that and transfer it back. X plus 7, 2x plus 3. X plus 7, 2x plus 3. So now I've got this whole thing factored. Let's see what will reduce out. I can get rid of an x plus 2, a 2x plus 3, an x plus 7, and I'm left with x minus 3 over x minus 7.
I had a quick question.
Yes.
Okay, you know how you crossed out the 2x plus 3's, those little brackets? So it's okay if they're on opposite sides, if that makes sense?
Mm-hmm. Let's talk about that question. That's a good question. Let's look at it. Let's go back to basic arithmetic. Let's say we have 2/3 times 9/4 times 7/8. Okay. In fact, let's add one more times 6/12. Okay. Can I reduce the 6 over the 12? Can I reduce that?
Yes.
Yes. Okay. Could I reduce the 6 and the 8?
Yes.
Okay.
No.
And let's look at why I can do that. Let's say that we didn't pre-reduce. What would we do? We'd multiply everything together like that, right?
Mm-hmm.
So ultimately, if it's all being multiplied, if you've got a factor in the numerator and a factor in the denominator with a common factor, you can reduce them down.
Oh, okay.
So let's apply that to this problem. This is all being multiplied. So really, ultimately, it would be one big numerator over one big denominator. So I could do what we're asking about. Does that make sense?
Yeah.
Yeah. Now, if there was a plus sign here, then I couldn't do that.
Oh, okay.
Because it's multiplication, it's all ultimately going to be the same fraction. That make sense?
Yeah.
Good, because if it didn't, I didn't have a plan B for description. All right, let's take a look at problem 29, and then we'll get on to some new stuff here. So this is 7.2, number 29, but that's a very good question. I'm glad you asked that. Perform the operation and simplify if possible. Okay, b squared minus 5b plus 6 all over b squared minus 8b plus 12 divided by b squared plus 2b over b squared minus 4b minus 12. So again, the first step is going to be changing dividing by a fraction to multiplying by its reciprocal. Hopefully my b's and 6's won't get messed up. Okay, so I'm going to factor each thing. B squared minus 5b plus 6. B, product is 6. Sum is -5. -2 times -3 is 6. -2 plus -3 is -5. Okay. Denominator. Product is 12. Sum is -8. -2 and -6. -2 times -6 is +12. -6 plus -2 is -8. B squared minus 4b minus 12. B. Product is -12. Sum is -4, -6, and +2. And b squared minus 2b, take out a b and we have b plus 2. Okay, so that's a 6 and that's a b. All righty, it's time for reducing. So those will go, those will go, those will go. And what do I have left? B minus 3 over B. Now, why can't I cross out the B's? Because this B in the numerator is not a factor of the entire numerator. Okay. We okay with that? All right, that was all the requested problems. Anybody that's here today that has any other questions you want to look at before we go on? Speak now or forever hold you.
Could we do number 11 on 7.2?
Okay. Hang on. Let's see. That was Danielle, right?
Yes.
Okay. 7.2. Okay, 7.2, number 11. Here we go. Multiply and then simplify if possible. P squared minus P minus 6 all over 5P minus 15 times 4P squared minus 11P minus 3 over P squared minus 3P. Oh, I don't know if I've mentioned it to this class. I mentioned it to my 85 class, but in WebAssign, whenever you're dealing with variables, you need to use the same case for, like, let's say that there's a capital A, and then in your answer, you use a lowercase a. It doesn't recognize it as the same thing and it'll mark it wrong. So be sure to keep the same case in your variables, okay? In fact, you might have a formula that has a capital A standing for one thing and a lowercase a standing for something else, okay? So just be careful of that. All right. Factoring each thing, we have P, let's see, minus 3 and a plus 2 would give us a product of -6 and a sum of -1. 5P minus 15, take out a 5, P minus 3. I'm going to do the bottom one, P squared minus 3P, take out a P, P minus 3. So I've got this thing to factor. I'm going to take that to the next page. 4P squared minus 11P minus 3. 4P squared minus 11P minus 3. So A is 4, B is -11, C is -3, product is -12, sum is -11, -12 plus 1. 4P squared minus 12P plus 1P minus 3. Grouping, take out a 4P, P minus 3, P minus 3 and a plus 1, P minus 3, 4P plus 1. Are you okay with that, Danielle?
Yep.
All right. P minus 3, 4P plus 1. P minus 3, 4P plus 1. I can get rid of, now here's, okay, so I can get rid of, oh, I guess they each one has a P minus 3. I could get rid of those two and those two, but I could also have crossed these two out and then those two out, doesn't matter. Let's see, what have I got left? I've got P plus 2 times 4P plus 1 over 5P. And there's your final answer. All righty. We good?
Thank you.
You betcha. All right, we're going to go on to section 7.3. And a couple of topics. The first one is adding and subtracting with like denominators. So basic arithmetic, if I have 3/8 plus 2/8, if I'm adding two fractions with the same denominator, I add the numerators over the common denominator. If I have 3/8 minus 2/8, if I'm subtracting two fractions with the same denominator, I subtract the numerators over the common denominator. Okay, let's apply that to algebra. Let's say I've got 9 over x plus 2 over x. That's 11 over x. If I have 4 over s plus 4 over s, that's 8 over s. Any questions there? All right. If I've got 7/10 plus 3y over 10, that's 3y plus 7 over 10. What if I've got this? B cubed minus 8 over 10b to the 4th plus 8 over 10b to the 4th. Well, that is b cubed minus 8 plus 8 over b, 10b to the 4th, which is b cubed over 10b to the 4th, but b cubed over b to the 4th is 1 over b. So I end up with 1 over 10b. Are we okay how I got from there to there? Everybody all right with that?
So even though both of them are b cubed, you'd still take away.
Oh, they aren't. This is b to the 4th.
I'm kind of confused on how you did that.
Okay, hang on just a sec. Back to the first person, whoever it was saying. Do you see that it's b cubed over b to the 4th?
Yeah.
Okay, let's take a look at what happened there. Okay. The rule is when you're dividing two powers with the same base, you subtract the bottom exponent from the top. But there's another rule that says if you have a base to a negative exponent, that's 1 over the base to the positive exponent. So I went from here straight there, but these are the rules. And these are back in section 5.2 again. Do I need to convince you more, or are you okay with this? Do you need more convincing?
No, I got it. Thank
Okay.
you.
Yeah, how about you? Nope. Okay.
Yeah, I'm okay.
All right. Anyway, so here's our answer. Be careful. You're reducing this down. You're not canceling it, because I'll have people that'll just write 10b, but no, there was a 1 on top, 1 over 10b. Okay. Now, how about this? Y plus 2 over 10z plus y plus 4 over 10z. So this is y plus 2 plus y plus 4 over 10z, which is 2y plus 6 over 10z. Okay, so now I've simplified it down, but I can factor a 2 out of the numerator. So now that 2 in the numerator is a factor of the entire numerator, and I can reduce 2 over 10 to 1 over 5. So now I've got y plus 3 over 5z. How are we doing? Fine, as long as we stay away from those exponents, right? Okay, how about this one? Let's see here. 2 over r squared minus 3r minus 10 plus r over r squared minus 3r minus 10. So that's r plus 2 over r squared minus 3r minus 10. Now, why did I write r plus 2? Why didn't I write 2 plus r? I could have, but I just like to put things in standard form, descending powers. But we're not done, because I can factor the denominator into r plus 2 times r minus 5. Product is negative 10, sum is negative 3. Okay, so now these reduce down to 1 over 1. Final answer, 1 over r minus 5.
I have a question. Why wouldn't we cancel out the whole r plus 2 instead of just the 2's if they both have-
Oh, sorry.
Oh, okay.
That was sloppiness on my part.
So it's r minus 5, right?
Yes, yes.
Oh, okay.
Yeah. Sorry about that.
That's okay.
Okay, let's see here. Now, what about this one? Y plus 8 over 2y times y minus 14 minus y over 2y times y minus 14. Okay. So that's y plus 8 minus y all over 2y times y minus 14. Common denominator. The plus y and the minus y reduce out. I've got 8 over 2y times y minus 14. But I could reduce the 8 and the 2 to 4 over 1. So now I've got 4 over y times y minus 14. Are you okay with that?
Mhm.
Now comes the situation where people tend to mess up. So watch closely. 5x plus 8 over 3x plus 15 minus 3x minus 2 over 3x plus 15. Now, the denominator is going to be 3x plus 15, right? Here's where I've got to be careful. This is the typical wrong thing that students write. Can anybody tell me what's wrong with that?
You have to distribute the negative.
Right. So what I need to do, let's do this, is I'm going to put parentheses around it because I'm subtracting that whole numerator. So when I go to distribute it, I'm going to get minus 3x minus negative 2, which is a plus 2. And right there is what people tend to miss on this problem. You're subtracting a quantity, you've got to distribute. And you can do it from here to here if you want, or you can do it as a later step, but make sure that you distribute that negative to the entire second numerator. Okay. I can promise you 99% that you'll have one of these on the test. I say 99% because I can't remember for sure, but I'm pretty sure. So now combining like terms, 2x plus 10 over 3x plus 15. Factor a 2 out of the top and a 3 out of the bottom. Reduce out common factors. Final Jeopardy answer 2/3. Okay with that? Let's do another one to make sure that you've got it. 8a squared over 2a plus 5 minus the quantity 4a squared plus 25 over 2a plus 5. So that's going to give me 8a squared minus the quantity 4a squared plus 25 over 2a plus 5, which is going to give me 8a squared minus 4a squared minus 25. So distributing that negative, subtraction, all over 2a plus 5. Combining like terms, 8a squared minus 4a squared is 4a squared minus 25 over 2a plus 5. 4a squared minus 25 is the difference of two squares. 2a plus 5, 2a minus 5. So now those two factors reduce down. Final answer 2a minus 5. Okie dokies. All right. Now we're going to talk about least common denominators. And I want to refresh your memory with some arithmetic examples, how this works. Let's see, I've got 6 plus 8. We'll go 5, 6 plus 3 eighths. Okay, 5, 6 plus 3 eighths. Common denominator. Now, some of you might be able to look at that and go, oh, it's 24. Others of you might say it's 48, which is a common denominator, but not the least common denominator. So let me remind you of the process you go through if you can't just see it. To find the least common denominator, you do the prime factorization of each denominator. 6 is 2 times 3, 8 is 2 cubed. The least common denominator is the product of the highest power of each different prime factor within any of the denominators. So I have 2 and I have 2 cubed. 2 cubed is a higher power than 2. And I have 3 to the 1 power. 2 cubed is 8 times 3 is 24. So your least common denominator is 24. Now, that may seem like a tedious long process and you might be going, oh, I don't need that. I can see this. Maybe so. But where we're going, you're probably going to want to use this when we get into the algebra stuff. So here comes the algebra stuff. Let's say I've got 4 over 9y and 11 over 3y. What's the least common denominator of 9y and 3y? Anybody?
9.
What?
9.
9? No. It's 9y. You see it? Danielle? You see it?
Yeah, I just didn't say the Y, sorry.
Okay, and I thought maybe you were cutting yourself off there. So, okay, how about this one? (12 m to the 4th, 18m). What's the least common denominator? Well, let's see. 12 m to the 4th would be 2 times 3 times m to the 4th. So 2 squared times 3 times m to the 4th. 18 is 2 times 3 times 3. So 2 times 3 squared times m. Okay, so the prime factorization of 12m to the 4th is 2 squared times 3 times m to the 4th. The prime factorization of 18m is 2 times 3 squared times m. So the LCD, I'm going to have what? 2 squared times 3 squared times m to the 4th, which is 4 times 9 times m to the 4th, which is 36 m to the 4th. It's the product of the highest power of each prime factor. How we doing? You okay? You getting this? If you're not, say so, because we haven't even gotten to the hard stuff yet.
I'm not getting this at all.
Okay, talk to me. Are you okay with how I'm coming up with these?
So when you come up with those, because I was trying to work on tonight's homework just to see what it was about, and none of it made sense. So when you do that, do you just use the lowest numbers possible? Or
So how am I getting this?
yeah,
Prime factoring. Do you remember what prime numbers are? Numbers who, okay. So I'm taking the 12 and breaking it down to 2 times 6, 2 times 2 times 3. So breaking it down. So 12 is 2 times 6 and 6 is 2 times 3. And then I'm just writing it using exponents so that I can identify the highest power of 2, the highest power of 3, the highest power of m, and then I form that product.
okay.
You sure?
No.
Yeah, I kind of get it too, but I'm not like completely there.
Okay, Do you want me to go back to just arithmetic for a little while, or you want to stay in the algebra? Doesn't matter to me.
I want to learn the algebra because, like, on
Mhm.
tonight's homework, we got some ones that are a lot more complicated than the one we're working on. So
Yeah.
I
Sure. Well,
need
we're
to
just,
figure it
like I
out.
said, we're just getting started. But if you aren't getting the simple stuff, there's no point to get to the complicated stuff yet. Okay, now consider this. 27 over c cubed d, 17 over 2 c squared d cubed. So my factors are 2's, powers of c, and powers of d. My highest power of 2 is 2 to the 1 power. Okay. I have c cubed and c squared. C cubed is my highest power of c. I have d and d cubed. D cubed is my highest power of d. So that is my least common denominator. The smallest number that this goes into and that also goes into. Are you seeing that or not?
Yeah, I see that part.
That one makes sense to me.
Okay.
Yeah.
Yeah. Okay, now here's where life gets a little more complicated. Oh, goody. Everybody says, how fun. Fun for whom? Now, here's where people make the common mistake. This D is a factor. This D is not a factor. The factor of the first denominator is that, oops, is that whole thing. So I've got a factor of D plus 9 and a factor of D. So my LCD is going to be D times D plus 9. But the mistake people will make is they'll go, oh, it's D plus 9, because they'll go, oh, because we've already got a D, so I don't need that one. Yes, you do, because this is not a D. This is a D plus 9. That whole thing is a factor because they're separated by a plus sign. That's the thing you've got to wrap your head around. I can see the Excedrin headaches coming on.
That one actually makes sense to me.
Well, good.
Yeah, it's
Okay.
more like when there's more numbers involved than
We're getting there. I still have 11 more minutes to torment you.
yay.
I plan on doing that as best I can. Okay, so my denominators are 5b minus 10 and 6b minus 12. But I need the highest power of each prime factor. So what we're going to do is we're going to factor each denominator. Tell you what, let me go back and let's do that slower. So I'm going to take out a 5. I get a b minus 2. You okay with that? So
Yeah.
the factors of that denominator are 5 and the quantity b minus 2. Here I'm going to take out a 6. But 6 is 2 times 3. So my factors of the second denominator are 2 times 3 times b minus 2. So my least common denominator, I've got a 2, a 3, a 5, and a b minus 2.
Oh, okay, that's starting to make more sense.
Good. So there's my LCD, or you could write it as 30b minus 60. Okay.
For that the b minus 2 on the left side and on the right side, you don't have to do like b minus 2 to the power of 2, because I kind of confused where that one went, if that makes sense. Oh, because it canceled. My bad.
Well, they don't cancel, but
Well,
the highest individual power is b minus 2 is just first degree.
okay.
If let's say that there was a 2 here and a 1 there, then we
Yeah.
square.
Oh, okay, okay.
Okay.
You just take the highest power, not a combination of all of them, just the one that's highest.
Perfect. Thank you.
Okay. So I'm going to factor the first denominator into that. So the factors of the first denominator are the quantity y plus 2 to the first power, the quantity y minus 2 to the first power. The factor of the other denominator is y plus 2 to the first power. So what's my highest power of y plus 2? 1. What's my highest power of y minus 2? 1. So again, there's like implied ones in all of these.
Oh, okay. See, I was putting those y plus 2's together, and I was thinking they were at to the second power.
They don't like each other. They won't even talk to each other. You can't put them
Okay.
together. They'll just fight.
Okay.
Okay. How are we doing here? Let's see. 44 over s squared minus 9. S plus 9 over s squared minus s minus 6. I'm going to factor the first denominator, s plus 3, s minus 3. I'm going to factor the second denominator, s minus 3 plus 2. So my factors are s plus 3, s minus 3, s minus 3, s plus 2, and they're all of degree 1. So what's the highest power of s plus 3? Just one of them, okay. What's the highest power of s minus 3? Just one of them. And the highest power of s plus 2, just one of them. Okay. We all right with that?
Yeah.
Okay. Now, this next section, people get confused by the directions and the way it's written out. So let me read the directions, write it out, and then tell you what it's equivalent to. It says, build each rational expression, remember that's an algebraic fraction, into an equivalent expression with the given denominator. All right, so it says 4 divided by y, semicolon 7y. So it says, build each rational expression into an equivalent expression with a given denominator. Now, in a Math 75 class, we would look at it like this. We'd say, take 4 over y and write it as something over 7y, okay? So this is the new denominator that you want to build to get to, okay? So what do I need over here in the denominator to multiply by y to get 7y?
7.
Therefore, what must I do to the numerator of that same fraction? What goes in the numerator? A 7. Because I can multiply by 1, okay? But I can't just randomly come in and multiply by anything other than 1. So my new numerator becomes 28. Whatever I multiply the denominator by, I must also multiply the numerator by.
Oh, okay, that makes sense.
Yeah, you've heard that before.
Yeah.
Far away. Okay,
And then on those ones, we do not reduce, right? Because then you would just end up with 4 over y.
exactly. There's a time to build, there's a time to tear down. Right now, we're building. Later, we'll tear down. Later, we'll build, put them together, and then tear them down. How fun is that? Okay, how about this one? 7 over y, x, y squared. So I want this to look like that. What do I need in the first denominator to get there?
xy squared. Oh,
What do I need in red? X. If I put xy squared there, I'd have xy cubed over on the right. What am I missing?
x.
No, I've got an x. What else?
Y.
There you go. Because that xy times y would be xy squared.
Oh.
You seeing it?
Hmm.
Let's go backwards. Xy squared divided by y would be xy. So going this direction. Okay, so now my new numerator is 7xy, and that's my final fraction. Okay. What's missing? You need that on the bottom to get the new bottom. You need it on the top to get the new top. Okay. I hate it when they put 9s and A's together. So the question really is this. But what we need to really see is what have we got and what are we missing? So let's take that original denominator, this one right here, and let's factor it. Okay. So what am I missing to get to the new denominator?
A parentheses a plus 9.
And what am I missing? Just the, give me the Canadian answer. You said it.
I don't
Hey.
know.
A. You went further than you needed to. What's missing? The A. So you take the A times the A.
Oh,
Yeah.
okay.
You gave me the whole story and I just wanted the first line.
Yeah.
So the new numerator is A. And mine, or this over here, and then I get what? A squared plus 11A. Distributing. Because again, it's legal to multiply by 1. So if we multiply the denominator by some number, we got to multiply the numerator by the same number. Okay. So this is that. So basically, I want to get that to look like that. Okay, this is what was given in the original problem. Take the rational expression, rewrite it with a new denominator. That's this. So I factored the first denominator so that I could see what was missing. What's missing? What do I need over here in the denominator to make it look like that?
X plus 10.
So what's going to go on top there?
X plus 10.
So I'm going to get x plus 10 times x plus 7. Okay. And they may or may not multiply it out. Sometimes they do, sometimes they don't. Okay with this?
Mhm.
Awesome. All right. I will be back at 1:15 for an office hour. Otherwise, I will see you tomorrow. Just a reminder, if you have questions later in the evening, the Math Center's hours, where are they? Right there. Okay. Anyway, I'm going to stop the recording.